So, 5.4. We were talking about logs. You guys finish that 5.3 homework? Was that okay for you? All right, it's a big section. This one's even bigger. This is our last section that's on the exam. Next week's exam week, right? Tuesday is practice exam, so we'll do the usual thing. First hour we'll take it. Second hour we'll go over it for the practice exam number 2. It's already online. You guys know what? I had a couple people ask me. I want to make sure I'm clear. Yeah, it's in Math Excel. First page under announcements. That's where the practice exams are. We don't do Canvas at all. All right, so, all right, diving in here. So, what we're doing, so remember, we're starting logs, and so the first thing you got to do, it's like a new language. We need to learn to speak that language, and I talked about how you translate in and out of that language. That is, translate from normal power talk. And what's the rule? When you gain or lose, what do I mean lose? Cross out. So like if there's a log there and you cross it out, or if there's not a log and you bring it in. You know, changing languages, into the log language or out of the log language. Either way, gain or lose a log. Oh, gain or lose a log. I forgot the log, that's important. When you gain or lose a log, what do? The base stays the base. The other two switch. I'll say that probably a lot of times today in these next hour and 50 minutes. The other two switch. So the base stays the base, the other two switch. So here's the question. So log base 9 of 81 equals 2. By the way, notice every log statement has 3 parts to it. Now, at different times, they'll skip different parts, but really they're all there and they're understood to be certain numbers and things like that, and I'll explain as we go. You probably already know enough to know what I'm talking about. But anyway, there's 3 parts. There really always are 3 parts. That is, there's a base part, there's a lowered down part. He's lowered down on purpose. Right? He's indicating it's made to look like 9 to the 81. It's not really 9 to the 81. It's actually the reverse of that, isn't it? Because that's what a log is an inverse exponential. It's exactly what it is, which we'll see thoroughly today. So log base 9 of 80, which has got a base part, it's got a plug-in. This is like the holes in the toaster or something. That's where you would plug into a log machine. A log's a function. To realize all these things are functions. Pretty much everything we do is functions. Sine, cosine, tangent, all that trig stuff, those are functions, right? You have sine, you plug in. You have cosine, you plug in. You have e to the x, you plug in. You have natural log or regular log, you plug in. It's the holes in the toaster, meaning it's a function, meaning you put stuff in, it does something to it, spits out an answer, right? Log is no different. That's the input or the argument, the plug-in. So there's a base, a plug-in, and an answer to a log. Okay, so what do we do now? They want me to take that statement being said in the log language and change it out of the log language. How do you do that? Well, you cross out the log word. We're going to have no more log word. And the base stays the base, right? Base stays the base. So what's the base? Well, it's the 9, which means he continues to be low down and has something on him. But instead of the 81, these guys switch. Instead of 9 to the 81, it's 9 to the 2. 81 goes over there. And we go, well, of course. 9 squared is 81. We know that. And the log says, well, that's what I was saying all along in my little log language. So that's what we're doing. Good. Base stays the base, other two switch. Okay, so log base 9 of 1. Now, we're going to actually solve, because they're not giving me all 3 parts, right? They're giving me the base, the plug-in. They're not giving me the answer. That's what they're asking me for. So I'm trying to get an answer. So notice I'm not just translating. Let me show you what I mean. The last problem, all 3 parts were already there. I wasn't really solving anything. I was just stating the same truth in another language. Uno, right? You're just saying the same truth in 2 different languages. That's all I was doing on the last problem, or the first 4 problems. That's all you're going to do. But here with problem number 5, you're going to actually solve something. What do I mean solve? Because they don't have the answer there. The answer is not given to you. All right, so this will be our first log to solve. How do you solve a log? First thing is you just put an x on the right side. Because remember, you got to have all 3 parts, and that third part is missing. So you just call it x. That's like naming your pet. I'm going to call you Rover. I'm going to call you X. You can call it any letter you want. I'm just putting a letter over there to hold a spot. All right, now, how do we solve for x? Because x will be our answer, whatever x is. How do we do it? Lose the log, right? Because we don't speak log. Let's get out of the log language. That's pretty much what we always do. Just get out of the log language. So get out of the log. So lose the log. Base stays the base. And the other 2 switch. So these 2 switch. So instead of 9 to the 1, which is what that looks like, it's 9 to the x, and the 1 goes over there, huh? Now, the question is, can you tell what x has to be? Remember, we're trying to find x because x over here is the answer. So 9 to what power? Now that we're out of the log language, we can read it a little bit better. You know, it's in normal power talk now. 9 to what power is 1? Maybe we're not so clear on that. Or maybe you're just holding back. Don't hold back. 9 to what power is 1? 0. Does everybody know that? 9 to the 0 power is 1. I'll go with my pen here today. 9 to the 0 power is 1. Yeah, do you know that anything, so the answer is 0. So x is 0, that's the answer. We're done. Anything to the 0 power is 1. You aware of that truth? So this section, they're going to push us on the power rules. We've got to remember those power rules from algebra because we'll actually do them backwards. So why is anything to the 0 power 1? Isn't that a weird rule? I mean, so you're saying like 3 to the 0 power is 1? Mm-hmm. Yep. 17 to the 0 power is 1? Uh-huh. Why isn't it just 0? Wouldn't that make more sense? Doesn't it feel like math's just kind of making this up as they go along? Does it ever feel that way to you? No? When I first saw rules like that, I thought, really? What, are they just making this up? That's what it felt like. Did you know that that actually has to be the case? I don't want to spend too much time because I don't got too much time. But really quick, I just don't like math sitting there like it's... I like to show you the beautiful consistency of math. It actually has to be that way. Think about any number you want. Think about 3 to the 3rd power. What's 3 to the 3rd power? 27. 3 times 3 times 3, right? Now let's just go down the pattern. What's 3 to the 2nd power? 9, right? 3 times 3. What's 3 to the 1st power? Well, just 3. What? Now, next one will come 3 to the 0, right? Suppose we had no idea what 3 to the 0 is. You tell me. Look at the pattern. What's happening from 27 to 9? What's happening from 9 to 3? Dividing by 3. Dividing by 3. So do it one more time. Divide by 3. 3 divided by 3? See, it has to be. It has to be. Or another way you can prove it. Remember the subtraction rule? Like what's 3 to the 5th over 3 to the 1st or whatever? Remember that rule? 3 to the 4th, right? You subtract powers. Remember that? Well, then imagine if you put 3 to the 1st over 3 to the 1st. Do the same subtraction rule. 1 minus 1? 0. So what is 3 to the 0? What is 3 over 3? 1. So two different ways to prove to you. It has to be. Anything to the 0 power is 1. So want to remember, make sure you remember that. Anything to the 0 power is 1. So the answer to this one is 0. All right. Log base half of 32. Can you solve that one? So go ahead and pop an x on the right side. Just make it equal x. And then lose your log. Cross off your log. Base stays the base. Other two switch, right? And then see what you can do from there. Okay, so put down an x, cross off the log. The base is the half, right? That's the lower down part. The base stays the base, but these guys switch. Whenever you lose the log word, those guys switch. Instead of half to the 32, it's half to the x. And the 32 goes over there. Good so far? Technically, you're supposed to write it like this. I don't really care. I mean, technically, if I don't put parentheses, it only means the 1 is raised to the x. Whoops. And not the whole half. Whatever. You know what you mean. I know what you mean. But I'll put it on there just to be technically correct. Anyway, doesn't matter. What matters is the final answer. So half to what power is 32? That's weird. How can you take half to a power and get 32? How can you get bigger? Yeah. Do you remember? See here, they're pushing us. How well do you remember your power rules? So I'm glad to remind you of all those. So let's talk about that. Do you remember that if you have, like, what's 3 to the negative 2 power? 1 over 3 squared, 1/9. Remember, negative powers flip things to the bottom? Or if they're already in the bottom, flip them up to make them 2 over 1. You with me? Negative powers don't make a negative answer, do they? They make a positive answer by flipping it. So are we all clear with that? So two things you got to be really clear about. Anything to the, x to the negative n power is 1 over x to the positive, and it flips it. And then anything to the 0 power is 1. Got to be crystal clear on those two power rules from algebra, because they're going to make us do them backwards now. So we'll know really quick how well you know those rules. Does that make sense? Anything to the remember that from algebra? Anything to the negative power, it flips it. It doesn't make it negative, does it? Negative powers flip it, and then you just do the power, right? Okay, so here's the way you want to think. As you look at that half and you look at that 32, you want to think, oh, we got to flip that thing to make it 2 over 1 or just 2. And then we got to do a bunch of 2s. I got to count how many to make 32. So just take your calculator, just go, how many 2s? Just start multiplying on your calculator. You'll find it's 5 2s to equal 32. Or 2 to the 5th power, however you want to find that. It's 5 2s, then you go, oh, okay, this x needs to be 5, but it needs to be negative. The negative part of the power will flip it and make it 2 over 1 or 2, and then 5th power, 5 2s, 32. So the answer is negative 5. That's a funny looking 5. Is that good? We good with that? Questions? So negative powers flip, 0 powers 1. Ooh. So log root 2 4. Try that one. Put an x on the right side, lose the log, base stays the base, other 2 switch. Let's put the x, lose the log. Base stays the base, other 2 switch. Root 2 to the x is 4. They switch because log is inverse of x, but we're basically inverting. That's what we're doing. We'll see in a little bit. We'll look at graphs. Logs are inverses of exponentials. Anyway, so what power do we need on a root 2 to make 4? How many? So really what you want to ask yourself is how many root 2's multiplied will make 4? Well, 4 of them, as I just wrote. Because 2 root 2's, root 2, regular 2. 2 more, regular 2, 2 times 2, 4. So you need 4 of them. X is 4. You need 4 of them. We good there? The answer is 4. All right. Hey, let's do this right now. I think it'd be a good time to do that. You can do this on your calculator too. You guys have your calculators with you? Let me show you how to also get the answer on your calculator. You guys have your calculator. What's the log of, I don't know, 17? Oh, I didn't bring my calculator. So what's the log of 17? Somebody have that? Tyler, can I use your calculator?
Yeah, go ahead.
Thank you. Log 17. Log. I had a little trouble. Here it is. I'm getting 1.2304, blah, 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 blah. You guys getting that okay? Everybody good with that on your calculator? Now, here's my question. What's the base? I don't see a base on that log. Every log has a base. There's no such thing as a log without a base. Remember I said the 3 parts are always there. There's always a base, there's always a plug-in, there's always an answer. I see the plug-in and the answer. What's the base? Right? It just says log. The button on the key just says log. What's the base? 10. Do you know that? Remember that from algebra? If the base isn't showing, it's an understood 10. It's called the common log because it's the one most commonly used in real-life applications of logarithms. You know, that just happened to like anything else happens in any field where they do something over and over and over again. After a while they say, look, if I don't write the 10, I assume it's 10 because they use the 10 so often. That's just what happens. So if they don't write the base, it's understood to be 10. Okay, great. So we have a button on our calculator that can do log base 10 of anything. So if I ask you, hey, what's the log base 10 of 20? You can just hit the regular log button. For 20, it'll be log base 10. I'm getting 1.301, blah, 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 blah. Great, okay. How then do I do a log of a different base? Like, how do I do log base root 2, for example? Can I only do log base 10s? And then you can do natural log, which is log base e. We'll get to that in a little bit. But other than those two, is there no other bases I can do? How do you do, like, other bases? And the answer is you do them in 2 logs. Do you know that? That's what I wanted to show you here. I'll show you how to do this in your calculator. When the base is not 10, make it 2 logs. Yeah, let me get this out of the way here. Make it 2 logs, and the high, this one is higher up. The high goes high, the low goes low. This is the lower one. The low goes 2 logs divided, I should say. 2 logs divided. The high goes high, the low goes low. So in other words, this will equal log 4 over log root 2. You make this 1 log into 2 logs divided. That's how you do it on your calculator when the base is not 10. So when the base is not 10, the way you do it in your calculator, I want you to have this, you'll need this to double check. So when the base is something, if the base is just 10, then yeah, just hit the button. That's what the button does, base 10. But if the base is not 10, it's something other than 10, then you need to make it into 2 logs divided. And how do you know which one goes in the top or the bottom? The higher one up goes high, the lower one down goes low. Hit the buttons on your calculator. You guys getting the answer? It should be that 4. Just come out straight 4, which is what we got by doing it by hand. You guys able to get that? Try that in your calculator, log 4 over log root 2. And make sure that Tyler's calculator is able to do that. Let's see, log. So you got to do the root thing, you know. Yeah. Good? You guys able to do that? I'm going to try it on the calculator, Tyler. I just did it. Good? Questions? Is that okay? We having trouble? Are you getting that? You don't look too happy. I don't see anything. You give me nothing. Is that working on your calculator? Can you do that? If you're having trouble, grab me after. Because, you know, generally you type it in, but I know there can be weird stuff. Oh, make sure, you know, most of the calculators do a parenthesis, so make sure you close off that parenthesis. That might help, if I can say that at least. There's little parentheses, you got to make sure you close them. So yeah, so type that in. So yeah, so the way it would type in if you have like a older style calculator that does it all sideways is you would go log 4 divided by log root 2 equals. That'd be exactly what you'd type in. Like that. Good. Should come out 4. So you can get it by hand or by calculator. So how do we do logs that are not a base 10? We make them 2 logs. All right. Hey, let's try something. What's the log of 0? Can you guys hit log of 0 for me? On your calculators there? Answer is?
Domain error.
Error. Domain error. That's impressive. That's a very precise answer. How about the log of -1? Domain error again. Error. So my point in that is you cannot put 0 or negative
Syntax error.
into log. Oh, you probably did the minus instead of the negative.
I did negative. No, yeah, you're probably right.
So does that make sense? You cannot put 0 or negative into a log. So we have a new domain condition. Remember domain? Remember how we handle domain? Up to now, we have 2 things to domain. First, denominators can never be 0. Remember, domain says what can you not plug into the toaster or the microwave, or you shouldn't put tin foil in the microwave. You shouldn't put knives in the toaster. Things you should not plug in that'll mess up the machine. Well, you can't put zeros in denominators. We always have, whenever they ask us domain, that's one of the things we look for, one of the trouble spots. Another one is the inside of any square root. Remember, we say, hey, inside, you have to be greater than or equal to 0, don't we? Now we have a third domain condition. What is that? Log base, any base, the inside, the plug into the toaster for the log. We say, hey, inside of a log, you have to be just greater, not equal, right? Because it can't be 0, can't be equal to 0, and it can't be negative. Cannot put 0 or negative. So it's strictly, so it's almost like the square root, except it cannot be equal. It's just positive things, just greater than 0 things. Good? So that's a new domain condition for us. So that's what they're asking me about here. Let me go back and do the particular question they're asking now. So they're saying, okay, what do you got? You got h of x, which is a function, is log base 7, x to the 9th. I don't care about any of it except this part. I don't care about the base, that's 7. It's not, doesn't bug me at all. Whatever the base, who cares? The inside, you grab the inside, you say, hey, x to the 9th, you got to be greater than 0. That's the plug into the toaster, the log toaster function. So how do you solve x to the 9th greater than 0? Well, that just means x has to be greater than 0. Right, if you 9th root both sides. Just going to be x is greater than 0. You with me? So that, and they want it, oh, it says right here, so it's just all positive. It's got to be positive. That's the domain. All right, I'm going to move on if you're okay with that.
Of
Uh-huh.
numbers, it was log x2, like with the 2 on the bottom.
All right, let me look at your individual in just a second. All right, let's try this one. So natural log 1 over x plus 8. Same kind of, oh, natural log is just a special log. We'll talk about it in a minute, but for now, just whatever, it's a log. It's a log. This is the inside. And so we say, hey, inside, you've got to be greater than 0. You can't be equal to 0. You can't be negative. Inside, you have to be greater than 0. So how do we do that? How can that fraction be, greater than 0 means positive, huh? Greater than 0 means positive. How can that fraction be positive? Well, the top is positive 1. So basically, as long as the bottom is positive, positive over positive will be positive, right? So basically, it's just saying x plus 8, you've got to be greater than 0. You've got to be positive. Am I losing you? Does that make sense? Because if the bottom is positive, the top already is positive, never changes. The top has no variable, has no x. It's just positive 1 period on the top. The top's always positive. So as long as the bottom is positive 2, they're both positive, the whole thing will be positive. So it basically comes down to, hey, bottom, you've got to be positive. So bottom, you've got to be greater than 0. That's positive, right? So how do you solve that? Well, just jump the 8 over. As long as x is greater than negative 8. The bottom will be positive, and the whole thing will be positive. And that's good. So there it is. They wanted in interval notation, so that would be from negative 8 to infinity, huh? Parentheses. No bracket, because you're not right on the 8. Is that good? Making sense? Questions? Let's try this one. Natural log of 16. So did you guys have this? Hit the buttons on your K. You have a natural log button, right? Can I see the question you were looking at?
Oh, the question that.
Yeah. What was it? Or you can just say it. Yeah.
It was. Let's load. The answer says it's all real numbers except 0.
Yeah. See, that one's different because it's x squared.
Oh, okay.
So right. So x squared is always going to be positive. Right. I think anything you put in there, it's always positive except for 0. Yes, that's a good different question. Yeah, so a good question was asked. I didn't realize sometimes it varies the question. On this one, let me go back. I'm going back real quick, if you're tracking with me. What if, I'll do a what if. What if they made it log base 7 of x squared? That's what he was sharing with me on his, so we'll be on some of your homework. They'll make it x squared. Well, if it's x squared, when can x squared be greater than 0? Remember, you always take the inside. We always take the inside greater than 0. Let me bring it over here. So if it comes down to, now if it's odd, see up here I had an odd power. When can x to the question I got was an odd power. So when can an odd power be greater than 0? Right? What can you plug into an odd power that'll be positive? Greater than 0 means positive. Well, any positive number. Any positive number to an odd power will still be positive. But here, x squared positive. When is x squared positive? It's always positive. Except when it's 0 itself. But any negative or positive, right? Put in negative 3 squared. That's positive 9. The only thing you're not, so if it's even power, it automatically makes everything positive except for 0 itself. Are you with me? So the domain would be anything's okay except x can't be 0 itself. But all else is okay. All positives and negatives are okay, but not 0 itself. You're with me? You would say all non-zero real numbers in that case. Anything that's not 0. Right? See the difference? All right. Back to this one. So what you guys got? You get your calculator and answer here? Somebody got it? 0.826. Oh, they want 4? Oh, they want 3 places. Oh, is it round to 7? Is it 6?
Oh, yeah, round 7.
6 whatever, so it rounds to 7, okay. 0.827, yeah, round to 3 places. Good? You able to get that in your calculators? If you have any trouble, just come up. Don't even wait till office hours. Just come up. It'll take me 10 seconds to help you with the calculator. They're all a little different, so I can't really say one thing for everybody, but just come up. Just 10 seconds. I'll be able to straighten that out with you. This will be for your gain. Let's look at this. So can you type that into your calculator? It's kind of a little tricky. Well, it depends. If you have the newer, nicer calculators that show the thing like a big old fraction, vertical and everything, then not a big deal. Just type in what you see. It'll all be great. But if you have the older kind like I do that puts it all on one flat level, then you have to be a little careful with your parentheses. In particular, you have to put parentheses around the numerator and the denominator. So in other words, you've got to type in parenthesis, natural log 28, plus, it also puts parentheses around the little plug-in, parenthesis, divided by, parenthesis for the whole denominator, log, just a ton of parentheses here, log 28 plus log 14, parenthesis, like that. Gotta use yours again.
Yeah.
Thanks.
Hold on to it, bro. Back up
All right,
here.
so
Back up.
natural log 28. One of those is those last two are regular logs, aren't they? So I'm getting 2.3025. How many want 5? So that'll round to 2.303. 2.303 on that. Y'all getting that okay? By typing that in. So you got to be careful. So that's really an important lesson. Is everybody catching me on that? Because this will happen at other times too. I just was working with a student the other day in my office hours, so it reminded me how important it is that I tell everybody about parentheses around the numerator and the denominator. Y'all see that? Because why do you have to do that? Well, because if you don't, you guys with me for a second? Watch this, because I want to do all I can to sink it deep in your mind. So if I give you a reason, I remember things better when there's a reason instead of just some random fact that has no logic to it. If I give you reason, here's the reason. If you don't put the big parentheses, calculators are stupid. They don't know. They can't see this. They don't know what it is you're looking at. So if you just type it in straight, if I just type in 10 plus 10, or let's go 8. 10 plus 8 divided by 2 plus 4. If I just type in like that, it's only going to divide those two middle numbers. 8 divided by 2. Notice it'll do this. 10 plus 8 over 2 plus 4. That's what it'll do. It doesn't know that you want the whole thing on the top unless you put the parentheses. Then if you put the parentheses, then it goes, oh, the whole 10 plus 8's on the top and the whole 2 plus 4 is on the bottom. I see. It doesn't know. See what I mean? Otherwise, it'll just divide those middle two and that's it. That's not what you want it to do. Right? Everybody tracking with me? It does so. So when do you have to do that? Let me write a note. Whenever there's more than one item on the top or the bottom, must put parentheses around it. Does that make sense? It means around that top, that numerator or denominator. So that's not just here then. That's any time we're doing some fraction thing in our calculator. That comes up a lot. So that's why I wanted to catch. Tons of students have problems with that, so I want to make sure I'm clear on that. So when you're dividing things, parentheses around the whole top, whenever there's more than one thing. So for example, if I was going 2 times 3 divided by 6, what I need to do it? Yeah, parentheses though, because there's two things in the top. Like that, right? Whenever there's more than one thing. All right, I think you've got it. Let's move. All right, so you guys did that graphing homework, right? With all the homework for exponential, I hope. I hope you're keeping up with all that. So 5 to the x, and inverse function is log base 5 to the x. Okay, so here we go. What they're going to have me do is a function and its inverse. So the original function f is, or I'll call it f. F of x is 5 to the x. Can we graph that one real quick? They're going to have us graph them both, but let's start with him. So yesterday's homework, we graphed exponentials. graphed exponentials. Did you make it through that homework? This is a good point in time for me to say, how you doing? We're 7 weeks. This is in the 7th week. Yeah, 7 weeks in. Seriously, the number one thing about math and science is just keeping up, day by day by day. Have you done the 5.3 homework? Did you finish that and really get it down? If you're not, I just encourage you, speak the truth to yourself. Don't say, I can't do math. Say, I'm not doing what I need to do. So I'm not putting you down in any way. I'm just holding up the reality. You can't fall behind in math and science. You can't do it. It's not like a GE. It's Chinese, right? We're learning Chinese. You must keep up. Because I'm using all that right now. Right now I'm going to use all that. If you're fuzzy and you're not good with that, you're going to start slipping down and down and down. It's what happens. You must keep up. Every day you must do that homework. Keep up, keep up. Get the help. I'm there. Roberto's there. But you got to keep up. I know I've talked to many students. I'm working 93 hours, and I'm not 93, but I'm working 35 hours and doing this and that. I know, but I'm just telling you the reality. The reality is people don't pass math science because of discipline more than anything. Time management. If I was to say number one reason, I'm all over my own kiddos about in their math and science. Keep up, keep up, keep up. I know that my own tendency, you can't fall behind. So are you keeping up? Keep up. So how do you graph? Do you remember? We did that. That should be fresh in your mind. How do you graph an exponential? How do we do it? We did it yesterday. A times b to the x plus c. Remember, we went through that whole thing. A times b to the x plus c. How do you graph it? Right out here, that's the horizontal asymptote, right? Horizontal asymptote. So let me draw a graph right here. So what do we have? We have 0 out here, huh? So the horizontal asymptote is 0. Horizontal asymptote is 0. Let me put that on there. So that's just the flat dotted line. Remember exponential graphs always have a flat horizontal asymptote. By the way, logs, which we're doing today, are the inverse. So what do you think? If exponentials have flat dotted lines, logs, the inverse, are going to have vertical dotted lines, is what they're going to have today. So, right, and then what's the A? What's the number in front? Well, there's just a 1 in front, huh? So that's the A. What is the A? Remember? If you did last night's homework, you'll know. It's the jump amount. It's the jump from the flat dotted line to the center dot. Positive 1, so that means up 1. Up 1 will be where the exponential hits. And what do exponential graphs do in general? Low to high. Low to high. They do that, don't they? They come down for a landing, right? They get closer and closer to that flat line forever, and they rocket up on the other side. Unless there's a negative x or negatives that flip them and stuff. That's the general thing they do. Pretty much all of our graphs go up to the right unless they're flipped, right? All the ones we've memorized, huh? I can't think of any exception to that. They go up to the right unless they're flipped or something, right? So there we go. So there's how f of x, which is 5 to the x, looks in general. The 5 is no big, they're whatever the base, they all just rocket up. Good? Now, we want to graph on the same axis the inverse. What's the inverse function? Well, they're just telling us right now. We'll find them all in a minute. Log base 5 of x. Log base 5 of x. That's the inverse of 5 to the x. Okay, we'll prove it in a little bit. For now, let's just take it based on what they're saying. So if that's the case, what might the graph of that thing, if this is the original function, and log base 5x is the inverse, what do you think the graph looks like? Remember how we find the graph of an inverse? It's a reflection across the diagonal line. Remember that? Remember this diagonal line? If you reflect across that diagonal line, you get the inverse graph. So what's the inverse of this going to be? Instead of up 1, it's going to be over 1, and it's going to go like this. There it is, the graph of the inverse function, the log base 5 of x. So which answer is that? Well, I reversed the colors, but it looks like A. They did the blue for the other and the red for the other, but it's A, right? We good? So I just graphed that one by reflection. I just reflected it across the diagonal line. Now we're going to learn how to formally do it on our own without reflecting. So number 13. So we need to graph log base 3. So, all right, so I'm going to do for you what I've done for you with all the rest. I'll give you the basic form, and then we'll do the flips and the turns from there. So here comes the basic form. Log base b of x plus c. So that basic form graphs the following way. It's going to have a vertical asymptote. Where do you think? It's the c determines the vertical asymptote. But remember, anything next to x has the opposite effect, doesn't it? Remember, x effectors are opposite. So negative c will be our vertical asymptote. So back here at negative c will be our vertical asymptote. Good? Good to there. And then what does that mean about the log? And then, right, 1 unit to the, usually, let me just leave usually. Usually 1 unit to the right of that is the where log hits, and it goes like that. There's the log graph. Now, yeah, I don't want to get too specific because it's almost always 1 unit. It's not something we'll have to worry about. If we have to worry about it more as we go, I'll explain more. Excuse me. Anyway, so yeah, let me just hold off on that, and I'll just say for now, it's almost always 1 to the right of the vertical dotted line. Almost always. I don't even know if they're going to ever mess with that, so I don't want to give you more stuff to worry about than you need to. So let's see. If they start messing with that, I'll tell you more of the story. So for now, let's just say, hey, it's always 1 unit to the right of the dotted line where it hits. Okay, so notice something about log graphs. They are concave down. Have you ever heard of concavity or thought about concavity for a minute? Before? Exponentials go like that, don't they? This is an exponent like 2 to the x or 3 to the x or whatever. That's concave up, meaning it's like a bowl turned up. It's like a bowl turned up. That's what concave up means. Whereas the log is like a bowl turned down, isn't it? It's concave down, which means logs are slow growth functions and exponentials are fast growth functions. Right? That log keeps going up forever. He does, but he sure doesn't do it very fast. Right? See how that log is going up? He's never going to stop going up. He'll go up and right forever. He just does it super slow. Slow growth. Concave down, like a bowl turned downward. Whereas exponentials, they rocket up because they're a bowl turned up. So the concavity will be a real big deal when you get to calculus next semester if you're doing that. Second derivative tells you concavity, and you'll get all, it'll be a big deal. So you want to start thinking about the way the bowls bend in curves. Okay, so they're opposites, aren't they? These are inverse functions. Log is bowl down, exponential is bowl up. Okay, so let's try to get this particular graph then. So, looking at this graph, sure looks different than the normal one. So first off, where's the dotted line? X equals 1. That tells us that it's log, oh, what's the base? Base B, look at them, they're all base 3, aren't they? So, it just must be base 3. So log base 3 of X. Now, what's the C? Well, it's your vertical, but it's the opposite, so minus 1, huh? Y'all with me on that? Minus 1, because whatever's next to x, opposite plus 1 is the vertical. Notice it's in the parentheses, isn't it? Why? Because it's an x thing. Remember, anything in the parentheses is a right-left effect, whereas if it was out here, if it was like this, they'll do this sometimes too. Well, you can even see one of the answers that way. Where is it? This one. Don't buy that. That's for sale. Don't you buy it. Right? That minus 1 is not in parentheses. That means down 1. That's a y effector now. You see that one? We don't want that one. This one means down 1 because he's not in the parentheses. Remember, anything that's not in the parentheses is outside of the plug-in. Really, the plug is right there. The hole's in the toaster right here, and that's subtracted outside of the toaster. Make sense? If they don't put parentheses, it's a y effector. It's outside of x's little world. That's down 1. That's not what we want. that does something different. But I want you to notice for a minute that whatever moves the vertical asymptote line is inside the parentheses because it's a right-left effect on that dotted line. Whereas, opposite for exponentials. See, for exponentials, it's a number out here outside of x. It is a y thing that moves the horizontal up or down for the exponential. Everybody see that? That takes time working on these, practicing homework, thinking about these things. Okay, so let's get back to it. So it's basically this, isn't it? That's what oh, but it's been flipped. Yeah, the normal one goes up to the right like that. But ours has been flipped. Now, how's it been flipped? Has it been flipped vertically? No, that would be down like this. It's not been flipped vertically. It's been flipped sideways. It's been flipped over there, huh? It's a horizontal flip. Horizontal. That says horizontal. Horizontal flip. It's been flipped sideways. What causes a horizontal flip? Remember, negative multipliers somewhere make the flips happen, right? There's two places you can put it. You can put it in the front. What does that do if you put it in the front? Is that an X place or a Y place? That's a Y place. That's not in X's world. You're only X if you're in X's little world. That would make it flip down like this, wouldn't it? If you put a negative out there. So that's not what we're talking about. They've put a negative in here on the X, haven't they? They've made this negative X minus 1. That right there is the horizontal flip. Negative on the X. You with me? Negative on X makes a sideways flip. Now, if you remember, if you're tracking with everything real careful, you'd be doing really good if you remember all this. You might remember that if there's both a flip and a movement on the same axis, that things can get really sticky and tricky. In other words, if they move a graph sideways and flip it sideways, the order matters. And if you do the move first then the flip, or the flip first then the move, that makes things look funny. So because that minus 1 might actually be plus 1 is what I'm saying. Even though all the other things we said about opposite and blah, 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 not if there's two movements in the same, a movement and a flip in the same direction. That can kind of reverse things and be super tricky. Remember that? We ran into that about a month ago. And what do I generally say to do in that case? Just make a table. I say it's too tricky. I mean, I could give you all this detailed rule about, well, if it's sideways, actually the flip is first, and then we get way too complex. Much easier just to make a table at that point. So, because what I'm saying is this might be plus 1. You might now, of course, you might be thinking, no wait, you told us, Mr. Heron, it's whatever's here and it's the opposite. Yeah, normally. But if there's a flip and a movement, right? You guys track it? I don't want to spend too much time. I'm tempted to do a whole big story because I like you to see the beauty of the logic. But you see, the problem is if you move and then flip, you're actually going to flip to the other side and the negative will become positive. So fancy things happen. So what does that mean? Make a table. Make a table. And you won't need to work hard on this table. It's really simple. Just make a quick little table and just say, okay, look, I don't know if this is plus 1 or minus 1. I know it's minus x. I don't know plus 1 or minus 1. So I'm going to find a point on the graph. Look right there. Do an easy one. 0, 0. 0, 0 is on the real graph. So 0, 0 must make the real equation true, right? So I'll find out real quick which one's the real equation. So put in a 0 for x and plug into log base 3 of minus x plus 1. Try that. What do you get? Log base 3 of plus 1, because you put in 0 there. And the other one, if you plug into log base 3 of minus x minus 1, you'll get log base 3 of minus 1. Am I losing you? I'm plugging into both versions. Right? I'm plugging into log base 3 of minus x plus 1 and minus x minus 1. Plugging what in? X is 0, because I know I'm supposed to get 0, 0 in the real deal. It's supposed to give me 0, 0. So which one of these is the real deal? This one or that one? Can you put negatives in a log? He's an error. This is not the real deal. It's not the minus 1. It's the plus 1. It's the plus 1. You can check this on your calculator. Say, well, what is that value? Remember how to do it? It's not log base 10, so what do? Make it 2 logs, right? Let the high go high, let the low go low. Hit the buttons on your calculator, you will get 0. It is right. This is 0. That's the 0.00. That's the true deal. So the fancy thing did happen. It flipped after or flipped before or whatever. So it's minus x plus 1. Now which one is that? Minus x plus 1? Did y'all see it say? That's the same thing, right? Minus x plus 1 is the same as 1 minus x. There it is. Question? Comment?
Yeah, so how do we know if the graph is going to go towards the left or the right of the asymptote?
The normal.
Oh yeah, that's the flip. So the normal one, the typical one, if there's no flips of any kind, yeah, that's a good question. If there's no flips of any kind, it goes up to the right. Like pretty much all of our graphs do, huh? Exponentials, logs, anything I can think of, without flips, normally, the normal state goes up to the right. So when I see it going up to the left, I go, oh, it's been flipped sideways. And that's what told me the negative on the x, the sideways flip. And then how I figured out plus 1 or minus 1 was the table, and I noticed the plus 1 version led to the real answer. The minus 1 version led to something illegal. Even though, yeah, but it's plus 1, it's supposed to be minus 1 here. Yeah, the tricky flip thing happened. That's a rare one. That's a pretty difficult one. All right. This will use up, if you're doing good, for most people, I don't know, it depends on the person, but this section, 3-4 hours of homework. I can't imagine, unless you're way sharper than I was when I was a pre-calc student, 3 to 4 good hours spent on this section. There's about 8 problems in a row, maybe 9, that are long, but they are so valuable. I'm not assigning them just to torture you. I pick which ones, and I cut out as much as I can. But they are so valuable. To work through those 8 or 9, I'll show you some now. They're going to make you do inverse, forward, domain array, exponentials, logs, how they connect, how they inverse, domains and range. So valuable. If you do a good job on those 8 or 9, really understand them. Go to Roberto or me. If you don't get them, you'll come out the other end a master of this. If you chuck this, you're not going to learn this stuff. So do what it takes. The help is available. So I'll do what I can. Only got an hour. All right, so natural log of x plus 6. So they're giving me f of x is natural log of x plus 6. First off, find the domain. All right, so how do we find them? There are a million questions here. How do we find the domain? The inside of a log, inside, you have got to be greater than 0. Not greater than or equal, greater. Only positives in logs, right? Solve that, greater than negative 6. There's the domain, negative 6 to infinity, so I wrote it there. Good. Part B. Now the graph. All right, let's do the graph. All right, what is the, for the graph, what does the plus 6 tell me for the graph? Vertical, right? Logs have vertical. Exponentials have horizontal. Logs have vertical asymptotes. Vertical asymptote where? At negative 6. Remember, it's the opposite. Unless there's fancy flip things, we don't have that here. Everybody with me? We just did a really weird one a second ago. So back here at negative 6. At negative 6, there's a vertical. The rest of it, natural log. Natural log's just a special kind of log. Don't worry, just do the normal log thing. What it means is log base e, you might remember. Whatever, don't worry about it at all. So what do I do now? Is there any flips? Is there any negatives on x or negatives in the front anywhere? No. So it's just 1 unit to the right. 1 unit to the right, going up to the right. Done. Which one does that? Back 6, this one. Oh yeah, I've already checked the box, huh? Back 6 going up to the right. Good so far for part B? So the vertical is the opposite of what's next to x. And there's no flips of any kind, so the normal state up to the right. Like that, okay? Question C. From the graph, determine the vertical. Yeah, we got it. X is negative 6. Good. I'm going to go on. I'm going to roll down for part D if you've got that down. So now they're going to ask me on part D, they're going to say, okay, you did the log thing. That's good. Now I want you to find the inverse. So here's the original function again. F of x is natural log of x plus 6. Now they're going to say, find the inverse function. Well, how do you do that? How do you take a function and find the inverse? Was that in the last test? Or is it this test? I can't remember. Anyway, it's good practice. It's going to be in the final too. How do you find the inverse of any function? What's the general 2 steps for finding an inverse? I'm hearing crickets.
Y equals ln x plus 6.
Sure, make it y, yeah. Invert x and y, right? That's what inverse function means. X and y have traded roles. Domain and range have switched. Inputs, outputs have switched. X and y have switched. Invert x and y, solve for y. Remember, those are the two simple steps? So it's a good review. These are so valuable because they make you do everything. They tie it all in beautifully. Inverse functions, exponentials, logs, graphs of both, domains and ranges. It's like all tied in. It makes them long, but super valuable. So how do you find an inverse function? So we have y, this is y, f of x is y. So you switch x and y, don't you? So x comes out here, y goes in there. Everything else stays put, right? Remember, you switch just x and y, nothing else. That's step one, invert x and y. Step two, solve for y. Ooh, super valuable again. Now we have to do, it's like everything's in these problems. Now, how do you solve a log equation? All of a sudden, that's cropping up. That's because we got to solve this now. We got to solve for y. How do you do that? I got an idea. You can tell by my tone this is a crazy idea. Don't do this. I see this a lot. I'll just divide by the natural log. No. No. You don't want to do that. This is not multiplication. This is not ln times y plus 6. Everybody hearing me on this? Mm-hmm. I'm not doing the 1 now for you, right? You're not thinking about the weekend. Hold off those thoughts. Put them off to the side for just a second. You really need to hear this. This is not multiplication. This is function. This is like f of y plus 6 equals whatever. You can't divide by the f. That's what that's like. You can't do that. That's plugging into a toaster. That's why I'm always doing the toaster stuff, because I've seen this so much over the years. People see parentheses and they just think multiply. No, this is plugging into the toaster. This is function. This is like f of y plus 6. So we can't, it's in there. It's plugged in. It's not multiplication. So, well, then what in the world do we do? Remember half an hour ago? I want to translate out of the log language. How do you translate in or out of the log language? The base stays the base. The other two switch. That's what you got to do. Whenever you want to go in or out, when you got a log and you think, I don't want a log, you can lose it. You can lose it. Bye-bye log. What will happen? Not dividing, but a special log maneuver. Is everybody catching me on this? I'm raising my voice because I've seen over the years, this is really confusing for people. And they think, well, what are you doing? So remember, everybody catching me? There's a special maneuver just for logs. That's the base stays the base, the other two switch. That's that whole thing. So you got to realize that when you're doing logs. Base stays the base. Now, I don't see a base. What base? Every log has a base. Now, there's actually two, you probably know from algebra, two understood invisible bases. If they write the normal log word, they didn't. But if they had the normal log word and they didn't show their base, that would be 10, the common log. Right? If they write the normal log word, L-O-G, then that's 10. But they're writing ln. So if they write ln, what's the understood base? E. It's the special E 2 point whatever. Yeah, so put that in there. That's what they mean by natural log. It's the number that naturally occurred when they were doing stuff. So ln has an understood base of E. So you guys tracking with me? There's two understood bases. So basic log is 10, ln is base E. Otherwise, they'll show the base. Those are the two invisible bases. Okay, so what? Why am I into that? Well, because when I cross off the log, the base stays the base. The other two switch. You guys heard me on that. This is always how we solve logs. So who's the base? The E. He'll stay the base, and what? The other two will switch. What do I mean other two? Meaning everything else. Meaning this whole y plus 6 and this x will switch positions. Instead of e to the y plus 6, it'll be to the x, and the y plus 6 goes over there. Does that make sense? See how they swapped? Super important, but I know not easy. So I want to help and be clear, right? Everybody gets all confused right here, and I understand. I did too when I was a pre-calc student. It's very confusing. So everybody see that? You can't divide by that ln. The way we get rid of logs is cross them off, base stays the base, other two switch. Log is gone. We're out of the log language now. And now it's easy to solve for y, huh? Now just jump that 6 to the other side. Y equals e to the x minus 6. There's the inverse function. Look at that. An exponential indeed is the inverse of a log. We just proved it. It's true. And now, last step, oh, no, two more. Then they want the range of f. Then they want, did they ever ask the domain? No. They want the range of f, and they want the graph. Okay. So let's do the graph first, actually. So let's take that e to the x minus 6 now and graph it. You all know that's an exponential. You all know how to graph exponentials. So I'm kind of scribbling all over the place. Is it okay if I just go to a fresh screen here? Y equals e to the x minus, what number is this? Number 17. So we want to graph that. Okay, so how do you graph it? What's the minus 6? Horizontal. Remember, there's horizontal asymptote on a exponential, down 6. Down here, like that. And then what do you do from there? E, remember, E, don't be freaked out by E. It's just 2 something special number. Who cares? What's in the front here? There's an A. Remember, it's A times B to the x plus C, right? So the A is 1. That's the jump. Up 1. Up to negative 5. Right? And then e to the x, there's no flips. There's no negative on the x. There's no negative in front. There's no flips. So up to the right it goes. Like that. Is that good? There it is. So, hey, and by the way, what's the domain of that? Because they're asking me for the... Oh, no, actually, let me be clear. They asked me for the range of f, the original function, f of x, which was, what was it? A natural log of x plus 6, that's what it was. Natural log of x plus 6. They asked me for the range of the original function f. This is the inverse here. Yeah, sorry, I wish I'd done it more clear. This is the inverse, which was e to the x minus 6, right? Am I doing that right? Yeah. So this is the inverse function, e to the x minus 6. They're asking me for the range of f. The range of f is the same as the domain of f inverse, huh? Remember inverse functions, right? We did that before, domain and range. See, all these issues tie beautifully in these like 8 problems. So many lessons are just reinforced strongly. So if they're asking me for the range of f, I think, oh, I can get that. I'll just get the domain of f inverse, because domains are easier. Just do domains, right? So you can just find the domain of f and the domain of f inverse, and then they trade to be the range of the opposites, don't they? So don't ever find any ranges. Just find domains and then trade. So if they want the range of f, I go, no, I'm not going to do the range of f. I'm going to do the domain of f inverse. So here it is, domain. This is f inverse. This is the graph of f inverse. So look at that graph. What's his domain? Well, how far left does he go? How far right does he go? Left edge, right edge. Negative infinity, positive infinity. He goes left and right forever. So that is the domain of f inverse. That is the range of f. Actually, we didn't need to do that. We could look back at the picture. What was the back here? Yeah, here is the picture of f. This is f, the original. What was his range? Yeah, you can just tell from the graph, huh? He goes up forever, down forever. So that'd be easy to tell that way too. And there it is. There's one question. All those parts. None of it's fluff. All of it's valuable. Is that good? Try another one? Questions on all that? All right. Because we just don't have time. But I'll do what I can. So, all right. So y, so the original function, f of x, minus 6 plus natural log x. They want me to graph it first off. Can you graph that one? Let me give you a second. I want to just whip them out, but I want you to be engaged with me, so let me give you a second. So natural log has a vertical, right? Find his vertical. Right? Exponentials have a horizontal dotted. Logs have a vertical dot. Logs take a dive somewhere, don't they? So where's his vertical? 0. 0. That minus 6 is not his vertical. Right? Because remember the general setup? It's whatever's in the parentheses with x. Right? Remember the original setup? Wherever it was back here. See, it's what's in the parentheses with x. On that, remember, yeah, there's what I gave you the first setup. See, it's what's in the parentheses with x. Whereas for exponentials, it's what's outside. So you got to really spend time. You write them on your 3x5 card, but it's going to take time to really get those distinctions clear and not be fuzzy and mess them all up. So what's in the parentheses with x? Nothing. So it's 0. The vertical is right at 0. Everybody see that? The vertical is at 0. Is that x equals 0? The vertical is at x equals 0. Well, then what's that minus 6? Down 6. All right, so where's... So are there any negative signs multiplying anything? No. That negative 6 is not. That's just subtract 6. That's just down 6. There's not a negative on the log here. There's not a negative on the x there. There's no flips of any kind. You with me? There's no flips. So this log does the normal thing, which means what? He goes up to the right. Like that. Now, what about that minus 6? Yeah, technically, this 1 unit to the right is actually down 6. 1, 2, 3, 4, 5, 6. So it's really right there. It's not going to make a big visual difference. It still goes up forever. It still goes down forever. So it's not a huge visual effect since it goes up and down forever anyway, moving it down 6. But yeah, technically, if you want to know where the over 1 dot is, it's over 1 down 6. That's where it technically is. So which graph is right? Yeah, it's C. You can see I've kind of messed it up, but there it is. It's C. It's down. See, it's over 1 down 6. On that, that's what that negative 6 is. That's a y effector, huh? This right here is a y down 6. Because it's not in x's world, right? We good? What's the domain? Are we good? Are we okay? I feel like I'm rushing over that point. Is that okay? That negative 6 is down 6. So you got to be real because it's still reinforcing x effectors, y effectors. So now, what's the domain? Left edge, right edge, domain. Yeah, 0 to infinity. Right, it goes from 0 on the left to infinity on the right. Right, it takes a dive here. It never crosses that vertical line. As you know, they never do. Cross vertical asymptote. So 0 to infinity is the domain. That, of course, will become the range of f inverse, won't it? In a minute, they're going to ask me, why don't we just do it right now? They're going to ask me the range of f. We can just see it on the graph here. How high, how low does he go? Negative infinity, positive infinity, huh? Let's keep going. Vertical asymptote, x equals 0. We already answered that. Now, the inverse function. Can you do it? Let me go to a fresh screen. What is it? Negative. I've got it so messed up now. What was it? Negative 6 plus natural log plus natural log of x. Okay, so it's f of x is negative 6 plus natural log of x. Okay, guys, real valuable practice. Find the inverse. Let me give you a minute. You'll get much more out of it if you try it first. So find the inverse, right? Invert x and y, solve for y. Which means at some point you're going to need to lose the log. The base stays the base, the other two switch. How you doing? What to solve there for x? What should I do for y? I mean, so switch x and y. Switch x and y. Now we need to solve for y, right? Those are the two things we do for finding an inverse. So how do we solve that for y? First, we add that 6 over, huh? We good to there? Get that natural log alone. So you get the ln alone, and then you cross or lose the log. Lose, cross out the ln. And what happens when you lose or cross out the ln? Base stays the base. Base stays base. Other two switch. So I'm going to cross off the log. And when I do, so you always get the log alone and then you cross it off. And when you do, the base stays the base, the other two switch. Who's the base? There's an understood invisible E for natural log. If it was regular log, the base would be 10, right? And so you cross out the log, base stays the base. The other two, what other two? Meaning everything else. The whole x plus 6 and the y, everything else, switches positions. Instead of e to the y, it's e to the x plus 6, takes the place of the y, and the y goes there. So it's kind of tricky. We have two switches here, don't we? So this is a complex process, takes lots of practice. We have the original switch for inverse function. That's because, you know, that's what it means to find an inverse function is to switch x and y. And then we have this switch for log. So it's pretty tricky. A couple of switcheroos here to keep all that straight. So we got it. There it is. That's the inverse function. We got y alone. It's e to the x plus 6. No surprise, the inverse of a log is an exponential, huh? But it's a little different than the last one. The last one, I think the plus 6 was in the front, wasn't it? This time it's in the power zone. So it's a little bit of a different story. Now they want us to graph that. Can we do that? Let's go to a fresh screen. You guys okay with that screen there? Well, I can leave it there for a second. Go ahead and graph that now on your own paper. Graph that exponential. And you know what it should look like. You could kind of look back. Once you have it, you can look back to the old log graph that we just did a minute ago, and it should be the inverse of that one. It should be the inverse of that. So in other words, here's the dotted line. It should be like up here, shouldn't it? You see that? Because that's going to be the inverse of that log, isn't it? Generally, that's what it's got to look like. You kind of know what it generally should look like. Because remember, inverses are reflections across the diagonal line, huh? So go back. Oops. See, so go ahead and do what we learned about how you graph exponentials, but you know what it should look like. In general. Is that good? Are there questions I can answer? I feel like I'm begging you for questions all the time. Please ask them, even if you think, oh, that's a dumb question, or nobody has that question. Everybody has the same questions. Let me comfort you. Everybody has the same questions, and whatever you ask, probably 10 other people are wondering the same thing. It's helpful to all. And I forget, you know, I'm just an old guy now. I've been doing this stuff for 25 years. It just all seems very natural to me. So I forget what's weird at times. So it's helpful to us all. Please ask if there's something that seems weird. Probably seems weird to many. All right, so how do you graph that right there? So we learned in general, a times b to the x plus c. That's the horizontal asymptote. So what number do we have added? 0. That's our horizontal asymptote, 0. So let's do that. And it's horizontal. Like that, okay. And then what's the a in the front? It's just 1, so 1 unit above. Is that good? But what is and there's no flips, there's no negatives on x or in the front or no flips. So it's going to go up to the right like normal. But what's the x plus 6 going to do? Left 6. Right? Because x is always opposite, and that's in x's little world. That's x's little world up there. Whereas if it was like this, then that 6 would be up 6, huh? Because that would not be in x's world. That would be different. We had that a minute ago. Something like that, right? Everybody see the difference? If the 6 was on the base level, not climbed into x's little world, then it would just be an a y effector, not in x's world, an up 6. But this 6 is in x's little world. So it's a right-left thing, and that's always opposite, so it's left 6. So that means this dot, this center dot, will actually go 1, 2, 3, 4, 5, 6. It's actually right there. It's actually back 6, up 1. So the up 1 happens at back 6 instead of at the origin. But otherwise, it's just like, you know, and then up and away. Like that. That's what we were expecting, huh? Because that looks like a mirror reflection across the diagonal line of the original log graph. Right? Going back here. See how it has to hit way over here? Yeah, because this one hits way down here. See, that point has to be reflected up here. See that? All that beautiful symmetry and the logic of everything, the inverse functions and the reflections, domains and ranges. Is that good? Questions I can answer? So these take like 10 minutes each, don't they? Oops, that was a mistake. There we go. All right, so log base 5 of x equals 3. All right, these will be quick and easy. So this wants me to solve. Nothing more fancy than that. How do you solve a log? Cross off the log, switch them around. Yeah, lose the log, base stays the base. Other two switch. Instead of 5 to the x, it's 5 to the 3. X goes over there. X is alone. 5 to the third. Choose your calculator. 5 times 5 times 5. It's 125. Done. Pretty easy. Just cross off the log. Base stays the base, right? Other two switch. Be good with that. I'll move on. So we'll try that one. Log base 2 of 5x plus 6 equals 2. Try that one. Cross off the log. Base stays the base. Other two switch. Cross off the log. The base stays the base. The other two switch. What do I mean other two? I mean everything else. This whole piece and this piece, they switch. Instead of 2 to that 5x plus 6 thing, it's 2 to the 2. And the 5x plus 6 goes the other side. Is that making sense on the switcheroo when you cross off the log? So that's what, 4 is 5x plus 6. Now just subtract 6. Negative 2 is 5x. Divide by 5. There it is, minus 2/5. Is that okay? So whenever we cross off a log, the base stays put, but all the other stuff switches positions. Instead of 2 to the 5x stuff, it's 2 to the 2, and the 5x stuff goes the other side. Then you just solve. So log base x of, oops, log base x of 324 is 2. So you know the drill, right? Lose the log, base stays the base, other two switch. So x is the base here. The other two, instead of x to 324, it's x to the 2. 324 over there. Now I guess you root it? Is that going to be clean? What do they want? Oh, it is clean? Oh, I just don't think of 324 as some root. What is it? What is it?
18.
Oh, 18? Oh, okay. Oh, okay. All right. I thought it was going to be something weird.
Minus on that?
Good question. Normally, yeah. A base, though, a base of a log is only positive. Yeah, for that reason, we only do positive 18, because it's a base of a log. They can't be negative. It's a long story, which we don't have time for. All right, we'll move. This one's super easy, but looks super weird. So it's natural log e to the x is 8. One thing I really want to help you with as you look at this. Notice that nothing is lowered down. You might look and go, well, there's the base right there. No, it's not lowered down, and it's meant to not be lowered down. That's not the base. Well, where's the base then? There's another invisible e right there. Because remember, there's always a lowered down number, isn't there? So if they're not showing a lowered down number, put it in there. So there's actually double e's there. Now, that's looking pretty weird, but don't worry about it. Just do the normal thing. What's the normal thing? Cross off the log. What happens when you cross off the log? The base, meaning this guy, the lowered down one, stays the lowered down one. And the other two, what do I mean by other two? Everything else other than that base switches position. See, I'm just following the same rules. Instead of e to the x, it's e to the 8, and the e to the x goes over there. Did you follow that maneuver? It's real. I'm just following the same old rule, aren't I? Now, can you solve that by observation? What does x have to be to make that true? Yeah, it's got to be 8. I'm not going to do any fancy maneuvers. It's 8. We're done. Is that good? You know what we learned from that? If you look back to the original, here was the original question. That a natural log and an e cancel each other out. X is just 8. They're opposites. That's what we just proved, really. All right. So log base 3 of 9 is 3x plus 1. All right, try that one. Same old thing, cross off that log, base is the base of the 2 switch. Do you need this? Want to solve problems? Do you need this?
No.
You
I
take?
got a second one.
All right. All right, cross off that log. Base stays the base. Other 2, switch one other 2, meaning everything else. Those trade. Instead of 3 to the 9, it's 3 to the 3x plus 1. The 9 goes over there. Good so far? Now what? It's easy to get stuck at this point and go, what's that?
Find a common
No,
base.
yeah.
Good. Remember? There's somebody who's keeping up with the homework. Yeah. Bases the same. Remember how we learned to do that? Make the bases the same. Yeah, that's 3 squared. Remember that?
Now you can single out the powers.
Yeah, once you make the bases the same, the powers have to be equal. Because if 3 to something is 3 to something, they got to be the same powers, or 3 to one of them wouldn't equal 3 to the other. So, 3, so you can cut out, you basically cut out the bases at that point. 3x plus 1 is 2, subtract 1, 3x is 1, divided by 3. Boom.
X is
1/3. Good? For all that? All right. Got that down. I'll keep moving. 1 or 2 of those graphs. All right. So E, whoops. E to the 4x equals 6. I'll let you do that one. Go ahead and solve for x there. There's a problem, huh? I want you to see it first off. This is different. Does everybody see this is different? Because what's different? Well, normally when we have x in the power zone, we make the bases the same. So we did right here, for example, right? We had x in the power zone. We said, all right, make the 2 bases the same, like that. It worked out, because you can make 9 3 squared. But what if you can't make the bases the same? Like here, I can't make e and 6 the same. How do I solve for x? I mean, what am I going to do? Like, could I divide by the 4x, for example? Well, no, that's not e times 4x. It's e to the 4x.
I guess square root 4x.
Some kind of root of 4x. But if I do that, even if that would do this, but then it would put the x on the other side. I mean, what are you going to do? You got e equals the 4x root of 6. I mean, what's that? That's not nice either. It doesn't seem any better at all. Yeah, good thought, but won't quite get us anywhere. Yeah, I mean, what are we going to do with this thing?
Natural log?
Yeah. You've got to get that 4x out of the power zone. You've got to get it out of there. So so let me just write a special note. Would that be the best way to do it? Yeah, let's do it that way. When I'm going to kind of jump ahead to something in the next section, but I think it's the best way to go. So when x is in the power zone, when x is in power, step 1, try to make the bases the same. But now we see you can't always do that. That's what we've always done up to now. if you cannot make the bases the same, ln of both sides, ln both sides, powers come down to the front. And ln of e is just 1. So here we go. I'm going to take ln of both sides.
So now we have ln of 6.
We get to there so far? So when you see, this is a note for sure you want to put on your 3x5 card. When x is in power, try to make the bases the same. We did a bunch of that last week. But if you cannot, ln both sides and powers come down to the front. What do I mean powers come down to the front? There's this special quality of logs, which really we're doing in 5.5, but I think it's the best way to go right now. Grab this 4x and bring it down to the front. There's a special quality of logs that says powers, you might remember that from algebra, powers come down to the front. So that 4x comes down to the front like that. It dethrones powers. It takes them out of the power zone and brings them down to the front like that. That good? Which makes it way better because x isn't in power anymore, which is what was causing us all the problem. And also, ln of e is just 1. So, because remember they're opposites, as we saw a minute ago? You tried it in your calculator. ln of e is just 1. So that just vanishes, and you just have 4x is ln 6. What's ln 6? I don't know. Some weird number. We'll get it in a minute. Good to there. 4x is ln 6. Now, how do you finish solving for x? Just divide by that 4. There it is. Hit the buttons on your calculator. Oh, they want exact answer. So that means they want that. They don't want a decimal because decimals go on forever and you round them, so they're not exact anymore. So whenever they say exact answer, they mean they don't want a decimal. They don't want a rounded decimal.
ln 6 over 4.
So type it in just like that. Yeah, ln 6 over 4. That good. Does everybody see that? So I really grabbed a rule from the next section. There is a way to do it using what we've already learned in this section, but it's a little different, and then in a week we're going to be doing this all the time. So I think it'd be easier for you if I just say, hey, here it is. This is what we're going to do all the time. Let's just do this. ln both sides. So special thing, powers come down to the front for a log. It's a special, next section 5.5, it's one of the 3 special qualities of a log.
Will we see some of these on the test?
Oh yeah, this is fair game. This is in this section.
So,
Yeah.
On the test, though, would you want the whole answer or just the decimals?
I don't remember. Well, you check it out that practice exam.
Okay.
I'm not sure which way I went on that. Because some of them they will ask for decimal in the homework and some. So, e to the 2x plus 9 is 11. So try that same kind of stuff. We got x in the power zone.
Got it.
So take the natural log of both sides, right? Natural log of both sides. And then that whole 2x plus 9 comes down to the front. And the ln of e, that's just 1. So it's just gone. Okay if I just cross that off? It's just 1, so who cares? Good to there. And then just solve for x. So subtract 9. Now when you subtract 9, guys, it can't go in there with the 11. Because remember, the 11's plugged into the toaster. That's inside the natural log. It's inside the toaster. Anything else we do is outside of that. So
Inside its own little world.
ln of 11, and then just the minus 9 is after it. You can't put it in the log. And then divide by the 2. They're just, what do they want? They want exact answer, so they want that. Just exactly that. There's nothing more we can do with that. Is that good? Questions I can answer? So, 5e to the 0.5x equals 7. So I should say, first get the base alone, then ln both sides. Yeah, so you first have to get the base alone. So in other words, first divide by that 5. Does that make sense? First get the base alone, and now take it from there. Now go ahead and do the ln of both sides, but you got to get that base alone first. And now do the ln of both sides. That's the extra wrinkle in this one. That's just one. Make it to there.
So it's ln of 750.
Now, am I racing ahead of you? You okay? To there. Last step, just divide by that 0.5. So there it is. That's what they want. Type it in. Just they want an exact answer. They want it just like that. Good. On that. Okay. Okay, so they give me this formula here. I don't need to read all those words. They give me this formula, 760 e to the minus 0.145h. So really, you know, in most word problems, all you really need to know is what the letters represent. Right here, P is pressure, and somewhere, H is height. H is height. So, okay, so they go blah, 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 pressure 381. So pressure 381, that means put that in for the P, huh? That's all I really need to know from the words.
So basically doing exactly what we've been doing, except instead of H, it's H.
And then I need to solve that for H. Does that make sense? So they're giving me the P, they're giving me the pressure. Like that. Plug that in, solve that. So how do I solve that equation for H? That's not easy. H is, where is H? H is in power. H is in power. That's difficult, right? When the letter climbs up into the power zone, that can make life difficult. So what do we do? Yeah, it's the whole get the base alone, ln both sides thing, right? So let's do that. So divide by the 760. That's probably some ugly decimal, is it? Do you guys, what's 381? Well, I got a calculator here. What's 381 divided by 760? If it is, I don't want to mess with it. Yeah, it is. So just leave it. If it's some ugly long decimal, I think it's easier just to leave the fraction. Oh, yeah, they probably want exact. Oh, no, they want decimal in the end. But I'm just going to leave it for now. 381 over 760. I'll just leave it because it's ugly. If it was clean, if I divided it was like 0.3, well, then, yeah, I'll just go with that. But if it's ugly, it's 0.501315, you know, blah, 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 blah. I'm just going to leave it. So I need a fresh screen if that's okay. 381 over 760 equals, what is it? E to the minus 0.145h. Do I have that right? Yeah. Everybody good to there? So I'm trying to solve for h now. So I'm just going to leave that fraction as it is rather than some long decimal. So you know the next step, right? ln both sides. So you get the base alone, ln both sides. And what happens? The power, come on. The power comes down to the front. So minus 0.0145h. That whole power comes down to the front. This is just 1. See how the ln always cancels out on one side because of the e, but it remains on the other side? And that power came down. So now it's just about dividing, isn't it? Just divide by that negative 0.0145, and h is alone. Negative 0.0145, and h is alone. There it is. And they want you to type that in your calculator and get the decimal. What was the decimal? It's 4.76. So can you get 4.76 out of that? Rounded to two places. We'll try that for just a second. Make sure you can get that. If you can't, come on up here in 6 minutes, and I'll be glad to help. So I'm going to move on. That's okay. That. Perhaps the hardest graphing one, number 23 now. So they're giving me f of x equals e to the x minus 3. So this time they're starting me with the exponential. Those other ones, they were starting me with the log. And I'm going to go backwards. So first off, they want me to graph the exponential. You know how to do that, right? That's pretty easy for you. The 2 is the horizontal, up to the horizontal asymptote, 1, 2. And the 1 in the front here, 1 times, that's your A, that's your jump. It's 1 above. 1 above the horizontal is where your exponential center dot is. What's the minus 3 do? Right 3, because x is always opposite. So this dot will go 1, 2, 3 to the right. And there's no negatives on x or multiplying the front of the e or anything like that. So it's going to go up to the right. Through that dot, up to the right. Good on that? See how this dot is moved over 3? And this is up at 2. So that's this graph right here. Next, horizontal asymptote, y equals 2. Now they want the inverse. Okay, so let me let you do that. Can you find the inverse of that function? So go ahead, give that a try. Find the inverse. We know it's going to be a natural log, huh? Because the inverse of exponentials are logs. And this is an e, so the inverse of e is natural log, because natural log is base e. Right? So, give that a try. So find the inverse.
X minus 2 plus 3. Yeah.
E to the x minus 3 plus 2. So find the inverse. So to find the inverse, this is y. Right? So to find an inverse, number 1, we invert x and the y. So the y becomes x, the x becomes y. And then we got to solve that for y. Right? So I inverted x and y. Number 2, solve for y. So how do you solve for y?
First was 2.
First move the 2 over.
Oh wait, no.
Just got to get y alone here.
Good
to
to
there.
inverse on both sides.
Good to there so far. So next step, trying to get y alone. Y is up here saying, I want to be alone. Get me off of this e and get rid of this negative 3. I want to be alone. How are we going to do that? Yeah. Where is it? Climbed into power. Climbed into power. I want to do all I can because it's so hard to remember it like out of context all of a sudden, isn't it? We got 2 minutes left. I'm a wannabe history teacher, right? I did all the math science. I thought history was super boring. In high school, it was so boring. My history teacher, wah, 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 totally boring. Junior college, fabulous. Mr. Magliari, he brought history alive. It was people and events. I thought, wow, history is really interesting. Too late for me to change things at that point. So I'm a wannabe history teacher, so give me 30 seconds, which will help the math. If the wrong person climbs into power, that's a problem, right? That's a problem. So I'm listening through Winston Churchill's biography, and they're talking about the days of World War II, Hitler, Stalin. Everybody always makes a big deal about Hitler. Stalin was 10 times as bad, by far. Hitler killed 6 million. Stalin killed 60 million of his own people. Horrible. But anyway, how did Hitler get in power? 20 seconds more. How did Hitler get in power? Was he voted in? Anybody know? This is kind of interesting. It was obviously a problem when Hitler and Stalin climbed into power. Hitler climbed into power he lost the vote. He lost the presidential vote. The people of Germany did not vote for Hitler. He became chancellor. He got second. He lost the election badly. Got chancellor, but then there were communist scare, and the rumor is that the Nazis were blowing up things around Germany to scare the German people. And Hitler, as chancellor, said, you know what, you need me to protect you. You better make the chancellor have military time powers. And they did. They passed some laws which gave Hitler second in command under the president, powers which eventually superseded the other. Anyway, so there we go. So the wrong person, I'm trying to help you remember. So when the letter's in power, that's when you need natural log. That's when you need it. So I want to try to help you remember. So when the thing you're trying to solve for, when it's in power, the thing you want, the thing you're solving for, what takes care of that? ln both sides. So you really have to just know it so well. So that means take ln this side, take ln that side. And what happens when you do ln? The power is dethroned, right? They tried to get Hitler out of power, as you know. You know, Valkyrie's I think, a very exciting movie where they showed one of the attempts on Hitler's life. Really, it would have been better to get Stalin out of power. But anyway, enough history. So, power, I'm trying to help you remember, when you do ln, you get the guy out of power. You get you get whatever's in the power out. That's a big special quality. Only logs do that. So you really want to remember that deeply. When something's in power and you're like, it's up in the power zone, how do I get it out? ln both sides. This is 1, this is y minus 3, ln x minus 2, add the 3, ln x minus 2 plus 3, y's alone. ... graph it from there. All right, guys, that's all we have time for. You have a good week.